Okay, so mass spec can be used for a lot of different things. It can be used to determine the molecular mass of a compound, right? So if you don't know what the mass of the compound is, you can use this device to do so, which is a key part of helping identify an unknown of a substance, okay? And then our main thing though is this. So if you're going to put a star by this last one, this is what you are going to be doing in this class. But once again, if you go on and continue to study chemistry, then you'll get to learn how to do the other ones, which are really cool. Okay, so we're just going to kind of go through once again the breakdown of how a mass spec works. And then we'll get to the graph and analyzing side of that. Okay, so once again, skip that video. So step one, the sample first gets ionized and vaporized, and that's what spreads them apart into all their individual atoms now instead of being clumped in groups, right? Because gases do not stay together, they spread out from each other, okay? And then these fragments are then what travel through the mass spec. Now, just side note, in case you're getting overwhelmed, I put a lot of words in this particular section because there's very little reading about the mass spec in our textbook. So I wanted you to have a resource to come back to if you need it. So that's why there's a lot of words in there, because literally page 52 is the only thing in your entire textbook about mass spec. So, okay, next step is then, that's where then you have your oppositely charged plates in the chamber to help pull or push them from one side depending on how heavy they are, right? Obviously heavy things don't get pushed as much as lighter things get pushed a bit harder. Okay, that magnetic field then, they continue to travel through with the positive and negative in the mass to charge ratio, which then can lead it to the detection plate, where then that's where we get our graphs from that show, hey, there's this many that hit here, this many that hit here, so on and so forth. Okay, so the strength of the magnetic field is varied to produce our mass spectrum. Okay, that's what our graph is called. And then this is what we're going to be looking at here, the key things. Is the peaks are going to give us a mass ratio of their height, which is going to help us to know like how much of it there is. And then the x-axis will tell you the weight at which it's at. So like any graph we read, you want to make sure you pay attention to the x and y axis to identify both of those patterns. Let's take a look at a graph. So this is an example of what a mass spec graph looks like once you are done analyzing and the data that comes out. So they're a type of bar graph, they're just really narrow looking often. The first thing you want to look for is what is known as the base peak. Okay, that's really the main objective for us because the base peak will tell you the most abundant isotope. And by knowing the most abundant isotope, I then can use the periodic table to identify my unknown substance. And we'll do that here in a second. But that's really when you see one of these graphs is find the tallest peak first, and that's really going to be the main focus. Now sometimes you might have, okay, some random fragments that are like way far away from the rest. Okay, that means there was something else in there making it not pure. Or in terms of like a compound, it didn't get broken down all the way. So they're kind of like outliers and you just ignore them, right? Because they're not, obviously, you're not going to have an isotope. Like if these are your average isotopes, you're not going to have isotopes that are like way up there, right? It just logically doesn't make any sense. Okay, now, nicely, this is actually more likely what type of graph you'll see. For AP, they kind of simplify the graphs a little bit. There's a little less data to stare at. But this, for example, is the mass spec of natural copper. So copper naturally exists as two isotopes. There's copper 63 and copper 65. When I throw copper into a mass spec, this is the data that I get. Okay? So the x-axis tells you the mass of that isotope. So this is isotope 63, this is for isotope 65. And then the height of the peak tells you the percentage abundance. So just like last time when we did those problems where we took the percent times the mass plus the percent times the mass, that data comes from this device. That's how they get it. And so on the same side, you could easily be given a problem where instead of just giving you the data, they give you a graph, and you have to analyze and calculate. We'll do one of those in a second here. Okay, questions so far? So once again, we did this problem last time, but just to show you that the data, this percent abundance, is what comes out from a mass spectrometer. Okay? Okay, everybody pull out your Chromebook, open it up and turn it on, and we're going to do some practice problems on there. Pull it open and go to Canvas for me.
What were the filling the blank?
Pass away. When's our first lab?
Okay, thanks. It's like a.
We're doing a kind of lab today. It's not a real lab yet, but I'm counting it towards your lab to give you a few points there that are easy. And it deals with like chemical stuff. I don't know if we have one in Unit 1. Unit 1 is like
Wait, when's the unit test?
the 20th
20th
September.
of September. Okay.
So like 3 weeks,
Okay.
something like that. Yeah, 'cause next week.
Okay.
Not next week, but it's on a Monday. I don't know about Monday this time.
Are we going to Canvas?
Yeah, go to Canvas and there's an assignment listed underneath called Mass Spec something. Study of Mass Spec. So open that up. We're gonna. This is actually your homework assignment, but we're gonna look at a few of them as some examples.
So we're gonna do a little bit of
Yes.
I was close.
Like two birds.
Two birds with one stone. You don't like that thing?
Okay, so open the quiz up, and I want everyone to scroll down. I think it's question 3. Scroll down to question 3 once you get it pulled up.
Hit take the quiz?
Yeah, hit take the quiz, and then scroll to question 3. So we're all looking at this again. So if you didn't hear or didn't catch on, this is one of your homework assignments tonight. We probably won't finish it right now, but we're gonna talk about a few of them as examples, and then you can use those to help you with the other ones. But okay, give me like a little wave of your hand if your computer's not ready yet. If you need over lots of you. Okay, we'll just keep staring at each other. Okay, give me another minute. Get that pulled up. Things going on today, by the way. So there's a football game tonight here, right? Against Orem. Should be pretty good because Orem is normally pretty awesome. And Pep Band, yeah. And then Sense and Sensibility. Are they still on tonight? Yeah. And then tomorrow there's only a matinee, right?
Yeah.
And then it's done.
And then it's over.
Main character.
Yeah, main character vibes. I don't know.
So if you haven't seen it yet, go see Sense and Sensibility. Do you have to get tickets ahead of time, or can they get them?
They're pretty much all sold out.
What is it?
It's pretty much sold out, but John Brown has like, I call them mercy seats. And it's like you can show up at the door at like 6:30 and buy tickets for like seats.
If you're lucky.
Like last minute.
Yeah.
At the
Okay.
door.
So if you want to, or I guess, do they ever, if no one shows, will they eventually give those seats up?
I think
I guess
so.
that's hard to know, huh?
I think it depends. It's just like
Because you're in the small theater, right?
Yeah.
Well, okay, I guess you can't go see it maybe, but good luck to those that have 2 more shows.
I closed last night. It was pretty emotional. Ooh. Yeah.
Okay, if you're still loading your computer, just listen as you load, but we're gonna move on here. So, okay, everyone look at this graph with me, okay? So, mass spec for an unknown isotope or unknown element, okay? Each of the peaks corresponds to an isotope for that element. First thing you do is you go to the base peak. So the base peak is the tallest one, so 74. This tells you the most abundant isotope there is. So I'm gonna take the mass, go to the periodic table, find something with a mass of 74. Now this is a common mistake. Some people go too quick and they're like, oh, 74, tungsten.
Nope,
Why not, Milo?
because it's the weight, not the.
Yeah, we gotta look at the mass, not the proton number. So, come over here. Oh, arsenic's close to 74.
But-
Now it's multiple choice. Is arsenic an option?
No.
So,
It's
closer to
Germanium.
no.
next thing I'd look at is where most of the peaks lie from the base peak.
Wait,
So since
Milo,
more of the
I
peaks
doubt
are below,
literally everything I say.
right, than above,
it's hard.
I know that it's probably gonna pull the average down from the base peak.
So it's germanium.
There's G,
Okay.
and that's your answer.
So it's
And this will be the case, like, if it's multiple choice, everybody, they don't, like, there's a reason, like, why they didn't put arsenic as an option, because it can get really tricky when it, like, have it without a calculator, because you don't have a calculator multiple choice, and you don't have to, like, do it in your head, of figuring it out, so, but just know that. But any questions on how we interpreted that graph and knew that it was germanium?
Wait.
Yeah.
Just to like clarify, you take, you take the base peak and then you see how many peaks there are above or below, and if there's more below, then you go to the next peak, next highest peak in that lower area.
Yeah, I would always first just go straight on, like, so I just say, I just found 74 first.
Okay.
But then if that's not an option, or once again kind of looking, because really arsenic is really closer to 75 than it is
Yeah.
even 74.
Okay.
So then, yeah, then you kind of look at where it's going to be pulled when you do that average. So,
Okay.
no, great summary of that. Okay, other questions before we look at a slightly different type of problem, but same concept. Okay, just FYI, so with your homework, you have this homework assignment and then the AP classroom quiz, right? Kind of use that as like a test after doing this, right? And to see how well you know it, because that is just more graph practice stuff.
They
So,
go in our grade, the AP classroom one?
yes.
No.
But remember, there's ways to make up points that you miss. Not through retaking, but
How do you make up the points that you miss?
stay tuned.
Penny of late.
It will come at the end of the unit. There will be, I'll explain it. There will be a way to make up those points. So, okay, everyone, scroll to number 1 with me now. Okay.
Correct. I know how to do that. That's
Now, this problem, obviously, if you read it, it tells you what element it is. But once again, same concept. You go to the highest peak, 293. Come over to the periodic table, and then you find something. Right, to identify what it is. Okay? On this problem though, what they want you to do is we are now going to use the graph to use the equation we learned last time. That equation of mass times percent divided by 100. Okay, so I'm not gonna say anything this time because I want to make you think for a little bit. So with your table buddy, I'll give you about 3-ish minutes. See if you can solve this problem. Ready, set, go.
Knowing that is
Yeah, feel free to use your notes like for some extra scoop if you need to write things down. But try out number 1.
The average, but you have to set the
Harry, do you know how to do this?
No, I'm just kidding. I think I do.
No, I have zero idea, like not even a single hint of idea.
You know that moment in the like the AP classroom quiz for the
And you were like, oh, okay, and then as soon as you turn it on, you're like, huh?
I figured it out. And I got 4 out of 5 because I forgot to play it.
Go boy!
How much did you
I
get?
got 5 out of 5.
I would have got 5 out
But I
of 5.
still don't get it.
I figured it out actually. It makes a lot of sense.
All right, take the equation we learned last time, apply it to this graph.
I have no idea how to do this. So take it one step at a time. So what are you trying to find? I have no idea. Good question. What are you trying to find? The average atomic mass.
Okay, so you're trying to find the average atomic
Are we
mass.
gonna get all of these 30 numbers and add them together and find the average?
Close. Oh, these are your, where's your notes? There's a white paper there. You're on the right track. It is an average, but if you remember last, yep, that's it. We're not doing a true average.
Okay, so we
We're
got
doing a weighted average.
Yeah, but where do you get that percentage?
Okay.
So look at your graph.
And then, wait.
So what's the graph tell us?
So you want like 291 times 2.
Whoa. So why would you times it by 2?
I don't know.
So this is the mass, right? What do I need to times the mass by?
The percent?
Okay, so I need to get a percent.
Yeah, but where is it? Is it like 20% or something?
Why?
I don't know.
Oh, it is.
Well,
So how could I get a percent?
by, by, I do not know.
In general, like if I want to know the percent of girls in this room, what would I do?
It's like divide or whatever.
Okay, that's a very broad term. Divide what?
By the number of girls by the amount of people in the room. There.
So we need to know how many girls we have and how many total there are, right? So look at your graph. Okay, you know you have 2 atoms in that. How many total atoms were analyzed?
This
Why is it 20%? That's what we need to make sure we know. Oh, we are times it by 20. So me, why would it be 20? So there were 10 atoms total. And if 2 of them, so that means.
So it'd be 20%. So 221 is basically 20% of the whole.
That's the mass of that isotope.
Oh, okay.
And then you can start to like mix these.
Okay, so this is 20.
Yeah, but this is weight.
Yes. Yes.
Essentially. And this is just the math, so and you multiply that, and then you multiply this, and you multiply that, and you add them together and divide it by 100. And then that's the answer?
Yeah, you're
Easy. Easy peasy. Okay.
Yep, good work. Once you do have an answer for that, I'm gonna give people like 1 more minute. But if you're done with number 1 and you wanna just look at some of the other problems while you're waiting, I'm always fine with that.
Wait, how many do we just do
OMG.
this out of the decimal? Or are we using seasonal?
Well, no, 100 to get the percent. Oh, well, that's just because.
I'm not gonna tell you straight up.
Well, it would just be the same.
Looking there, the key part.
If we're just going so then
People think they
so
have
it'd be 2 accurate.
Always round to 6.
74.
Whatever 6 things are, that's it. Hopefully I don't mess up when we get to 1 6.
It's like, how do you even hide it from
Okay, all right, everyone finish up the moment, what you're plugging in, and then give me your attention up here. I saw good things, but just a reminder in this class, okay? This sounds weird, but it's truth, okay? I would rather have you walk down the wrong path trying to solve something, and I have to come bring you back the other way, than you just stand and not try at all. Okay, there's so much that can be learned from going down, like, incorrect thinking to get it to the right path. Way more than if you just sit there and be like, I don't know what to do, so I'm just gonna wait. Okay, so just try something. Okay, AP chemistry is literally like a walk in the dark sometimes, and you may not know where you're headed, but just keep walking forward. I'll stop you before you fall off the cliff. Okay, but don't be afraid to just keep walking, because I promise you'll learn so much more, and it's so good for the brain that way. Okay, Alright, I'm gonna go through this one on the board so you can check your logic and your answer. Okay, so we're trying to find the average atomic mass, which is the red number up there, for livermorium. Okay, so we need a percent times the mass. Okay, one last thing too. If you feel like you got it right and you know what you're doing, give yourself a pat on the back. Okay, but when I'm explaining, I don't want you talking because someone else might need what I want to say. Okay, so no talking while I'm trying to explain for those that want me to explain, and if you're good, then good for you. Okay? Alright, so I'm going to take the mass, 291.2, and I need to times it by the percent for that thing. Now this is to show you there's a variety of ways the y-axis can be shown on these graphs. Sometimes it already is a percent, but sometimes it's by a ratio of how many were analyzed. And in this case, that's how it is, because it's just saying 2 of the atoms were this particular isotope. Now, conveniently enough, which they do for you on multiple choice questions, right? It says that it was out of 10 atoms total, or if you add them up, it adds up to 10. And so 2 out of 10 is my 20%, so I can just type it like so. And then I'm going to add the next isotope, 292.2 times by 30%, plus 293.2, and that's 50%. I plug that in, and I get an answer, and that's the right answer.
Okay, thanks.
I don't remember the answer. It's 290.
292.5.
Is that what you got? That's what I
Did
got.
you guys get
I
that?
like it way far.
Wait, so you don't divide by 100?
No. Amy, if you have the decimal point, then you don't have to divide it by 100.
It's just up to you, Amy. So like, I changed them to decimals, so I didn't have to divide by 100, but if you left them as 20, 30, and 50, then yes, you would divide by 100.
Factual, okay.
So either one
Factual.
works. Any questions on using this equation in relation to mass spec graphs?
Wait, I kind of get it.
Those moments in life.
Oh, queen.
I thought I got it wrong.
I really.
Okay,
Oh, I just typed something in wrong. Gotta go.
alright. Final call, everyone feels okay?
I started like 87 points.
I'm not going to tell you right now because I want you to struggle with it for a bit.
Of course, is it like 7? Oh, wait.
But I'll help you
292.5.
if you after. Okay, yes, you can have a smiley face if you got that one correct. And then we're gonna
What
take.
about a point one off?
How'd that happen?
I don't know.
Even too, like.
Do you have the? Did you do the rest? Did you just hit something on your calculator?
What? Yeah, I don't know.
Yeah, you can have it. Okay, and then put your laptops away. So save the quiz so you can save those questions you did, but the rest you're gonna do later. Okay? Save your quiz and put your computer away because it is magic school bus time, everybody.
No way. Are we watching Magic School Bus?
Oh no.
Oh, dang it.
With the Chris? No
Yeah.
way.
But not like. I'll explain. Just put your computers away.
How do we say?
Does it just save automatically if you don't hit submit?
Yeah.
I think that's how it works. Oh, I didn't know if there was an official save button.
Yeah, it's either submit or
So when you're like, wait, there's a button.
Like, just don't the homework. You do get 5 attempts, so I guess you could submit it. So you don't forget. Okay, and then for our Magic School Bus activity, everybody needs a separate piece of paper. So pull on a lined piece of paper. If you don't have one, maybe your friend can lend one to you.
Hashtag blending, hashtag friending.
You're full of catchphrases.
Yeah, for sure.
Okay, pull out a piece of paper, everybody. Yeah. Let me stop this and then I'll